So I'm going to go over box and circle collision. I have a process and sketch open here that demonstrates it. I'm going to show you how it works and go through the code and kind of talk about the idea behind it or the theory behind it, and then explain the code. Yeah, so the demonstration here is just obviously when the circle isn't colliding with the box is green. When it is, it goes purple. So yeah, I'll show you how that works, and I'll explain what that little red dot is. First of all, I'll go over the like why I decided to pick this one. I think it's pretty useful for if you're making games in processing, and I know there are other useful ones like rectangle to rectangle and line to line collisions, but I thought I'd choose this one because rectangle to rectangle is not too hard, and this one it's easy enough. It's hard to kind of figure out in your head, but I think when somebody explains it, it clicks really fast, and it's pretty obvious how it works. Um, so basically, to find out if the circle and the rectangle are colliding, you essentially get the closest point to the circle that is bounded on the rectangle. So that's what this red dot is. It's the closest point on the rectangle um, to the center of the circle. And you find that point, and then you get the distance between that point and the center of the circle. And if the distance between them is greater than the radius circle, like it is now, then they're not colliding. But if I move it down here and turn it to pink there, you can see the distance between the red dot, or the closest point to the center of the circle. The distance between that point and the center of the circle is less than the circle's radius, so they're colliding. And this doesn't only work in the edge, it works if it's in the middle, if it's in the circle, it works at the edges, it works at the corners as well, which what makes this kind of fantastic and makes it nice, and a nice accurate collision going on. Um, yeah, so first I'll just say I didn't figure this out on my own. Like I tried to think of it. I was going to use it for a breakout assignment a while back, and yeah, I couldn't really figure it out. Like the ball is the circle and the bricks is the rectangle. I was trying hard to figure it out, and I had to end up looking up online, and I got a lot of help from Jeffrey Thompson's website, which is a really good website on geometry collisions, and he goes about the theory behind them, the formulas, and the code about it as well, which is also JavaScript. So yeah, first I'll go over the theory. The first bit is to get the closest point to the circle that's bounded in the rectangle. So the way we get this is we first get the closest x position and the closest y position, so the x-axis and the y-axis. So first you want to check if the x position of the circle, if it's greater than the left-hand side of the rectangle, and if it's less than the right-hand side of the rectangle. If it's in between those 2 points, well then the closest x position to the center of that circle is going to be the x position of the center of that circle. So you can see as I move it here, the x position is aligned with the x position of the circle. And it makes sense why that would be. And the same thing with the y-axis. If we move here and if we're in between, if the y position of the circle is in between the top side of the rectangle and the bottom, well then the y is equal to the y of the circle. And it makes sense why that would be. And when it comes to like say the edges or the corners or whatever, for the x-axis, if it's less than the left-hand side of the rectangle, well then the x is going to be the left half side of the rectangle, because it can't go beyond the rectangle, obviously, because it's bounded by it. So if it's less than the left hand side, well then it's going to be equal, the closest x position is going to be equal to the left hand side. And the exact same thing over here. Like if it's greater than the right hand position of the rectangle, well then the closest x position is going to be equal to the right hand side of the triangle. Basically rectangle x plus rectangle width, assuming that the origin is here, the width and height. And the exact same thing on the y-axis. If it's less than the top half, well then the y is equal to the top half, or the top of the rectangle, or the rectangle's y. And if it's greater than the bottom side, well then the y is equal to the rectangle's y plus the height, or the bottom white rectangle. So when you get the x and the y and you put them together, you get this red point, which is the closest point to the circle. And basically when we get that, we want to find the distance between them. This doesn't only work in the edge. As I said, it works in here. You can't really see it, but the red dot would be moving in the very center of the circle, because that's obviously the closest point to the circle when it's inside the rectangle. Yeah, so I'll jump into process and I'll show you how to do that now. Yeah, so I commented out half of my sketch, and I'll rewrite it for you just for the purpose of learning. And the way we'd want to store, you know, the way we want to check these collisions between the circle and the box is using a function, a Boolean function. So this will return either true or false. True if they're colliding, and false if they're not. So we can call this function box to circle collision. Then we want to pass in 2, 3, 4, 5, 6, 7 arguments. These arguments are going to be the coordinates of the box and the circle and the sizes of them. So we can they're all going to be floating points as well. So we can have the position of the box on the x and the box is y, and that has to be a float as well. We have to get the box's width and the box's height. Then the same thing with the circle. We have the circle's x position, the center. We'll use the center as the x position, not like say the top, left or anything like that. And the circle y, and another float is the circle radius. I'm using floats here for each different variable. You could use p vectors for to save up the amount of arguments. The problem with that is if you don't have a p-vector set up, you might have to pass in a new p-vector, and that can get pretty messy when there's a good couple of p-vectors in between all these brackets. So I don't know, it really depends on your preference and your sketch and whatever. Yeah, so we have all these coordinates, and as I said, the first thing we want to get is the closest point, or the edge, or the closest edge to the circle. So this will be a floating point as well, because it's just a position, and we'll call it close x. If we use edge x, it's not technically right, because if the circle's inside the box, or inside the rectangle, it's not exactly closest to the edge, it's closest to wherever the center is. Now, what are we going to make these equal to? As I said, you check if it's in between, if it's to the left, or if it's to the right, or if it's to the top or bottom, if it's the y-axis. And we could check those three different states, or make those three different if statements, but the more optimal way would be to just check if it's to the left or to the right of it, and if it's neither, well then it's going to be in the center anyway. So we can actually say that the closest x position is going to be equal to the circle's x anyway, and then the same thing with the y. Yeah, so this will save us having to write a third if statement, so we can just write 2. So yeah, so first we want to see if the x position of the circle is less than the left hand side of the rectangle. So check left side of rectangle or box, or rectangle or box, whatever suits. So we'd check if the circle x is less than the box x position. Assuming the box x is the top right and not the actual middle of the rectangle. If you like using the middle of the rectangle, you might have to move around some of the variables. But just for the purpose of this demonstration, I'm going to assume that it's the top right, or sorry, the top left that you're going to use as the origin. So the circle's x is less than the box x, and if it is, well then the closest x position, is going to be equal to the left hand side of the box or the rectangle. So we could say close x is equal to box x. And then we'd do the exact same with the right side. So exact same if statement, except it's kind of flipped around. So if the circle X position is greater than the box's X position plus the box's width, box X plus box width will be the right hand side of the box. If we just said box X, well then it'd only be if the circle's X position is greater than the left hand side, which is not what we want. That'll kind of screw things over. So we say box X plus box width. And then if it is greater than that, we'd say the closest X position is equal to, again, the box's X, but this time plus the box's width, which means the right hand side of the rectangle. So this will basically like get us the closest X position to the circle. This is what we have so far. And this is like, we're already like more than almost halfway there. So we do the exact same with the y-axis. So we can say we can check the top side of the rectangle and we can check the bottom side. And we can just change all these x's except that one to a y. And this is basically checking if the circle's y position is less than, is above or less than the top side of the rectangle. And if it's greater, and we change width to height, and check if the y position is greater than the box's y plus the box's height, which is the box of the rectangle or the box. Yeah, so if the circle is less than the box's y, then the closest y position is equal to the box's y. If the circle's y position is greater than the box y plus the height, then we say it's equal to that position as well. So we have our close y position and we have our close x position. And what we can do with them now is we can display this on the screen now. So we can say fill 255 0 0, and this will give us a red ellipse. We can say the points will be close x, close y, and we'll say 60 by 16 for the width and the height. Now if we just ran the sketch now, nothing would happen. Actually no, we'd get a compiler error because this is a boolean function. We have to return a boolean, we can't just leave it. We have to return either true or false, and for the time being, let's return true. This won't change anything, it's just we have this just so the program can compile. So basically what we do now is actually check it. So we can say if, actually for the purpose, println, so this will print true no matter what because we're always returning true, and we basically have to pass through our boolean function box to circle collision. So we just fill in these arguments, assuming like you know how to draw the rectangle, how to set up these variables of the box's x position and circle's x and y position and whatever. Then I'll leave you to do this bit. It's really up to the name of your own variables. It's pretty straightforward, but I'm just going to skip on a bit. Yeah, so I'm basically printing out a line that's just going to say true because we're constantly returning true no matter what. And I'm just passing in the variables that I've set up for my sketch, which is the position of the box, the width, the height of it, and the position of the circle, I call it ball, and its radius. And if we do this, you can see the closest position to the circle is represented by the red circle. So this is kind of like what I showed you at the start of the video, except if we collide, nothing happens because we're not actually checking if it collides yet. So let's get to doing that. So we can keep this thing drawing, but basically all we have to do now is check the distance between that closest point and the center of the circle. So we can create a new flow called distance. Now, assuming you know how Pythagoras theorem works, it is basically the distance between 2 points, or two vectors or x and y positions is the square root of close x position minus the circle x position squared plus the square of the close y position minus the circle y. So this is basically Pythagoras theorem flipped around a bit, some variables moved over to the other side. And we use close x and circle x and we take them over each other, and this finds the distance between them on the x-axis. We do close y and circle y, which finds the distance between them on the y-axis. Square them, add them together, find the square root, and there we have the distance between the closest point on the rectangle and the center of the circle. Now we just have to do one last statement, and we just have to check if the distance is less than the radius of the circle. So if the distance is less than circle radius, which is one of the arguments, then we return true. And we're returning true because if it's less than the radius, then they are colliding. If it's not, well then it will continue on to the next line and it will return false instead. So basically, if it is less than the radius, it will return true, and if it does return true, well then it breaks this function, it breaks out of it, so it doesn't go on to the next line. And if that statement isn't true, well then it will go to the next line and it will return false. So instead of going println back up here, we should have this box to circle collision working. We can write if statement. If it is colliding, then we can set the rectangle's color to be purple. If it's not colliding, which is else, then it'll be setting it to green. Get rid of that line. Run this, and we have an error. And if we get rid of that semicolon, and we can rewrite it like that. Now I made a mistake here. I said circle instead of circle x. Save that, run it, and we have the sketch that I have from the start. The circle is following the mouse. We can see the closest position to the circle on the rectangle, and if we collide with it, it's gone pink. So you can see this works if the circle is completely in the rectangle. It works when it collides with the edge, and most importantly, and probably most usefully, it works when it collides with the corners. So like this is 100% accurate, it works really well. And yeah, that's basically it. You can use that to create breakout games, you can use it to create Pong games if the ball is a circle. Yeah, it's just if you're messing with circles, it's a bit more accurate and a bit more fluid to use this instead of box to box. Yeah, that's pretty much it. Thanks for watching.